Hey everybody, I'm Mr. Walsh,
I'm Mrs. Dominiak.
and
This is Ralphie.
Oh, look at Ralphie, there he is.
He loves benchmarks.
He does love benchmarks, doesn't he?
Benchmarks. He loves to mark benches.
Oh, yeah. I think that's a different thing than we're going to be talking about here. Yeah.
Sorry, Ralph.
Right.
Sorry, Ralph.
But we're going to spend some time, and we're going to be reviewing what the benchmark is for honors chemistry, and we can talk about it. You haven't seen the honors chemistry benchmark ever before. Yeah, it's exciting. So
I'm basically like your students, because I don't know, but I know the knowledge. Like, I don't know what's coming, but I know the knowledge, like they know.
Yeah, something like that. So that's pretty cool. Yeah, you're pretty good.
Let's do this.
So let me make this smaller. So just so you guys all know out there, the benchmark is going to encompass all this stuff. Ooh. Okay, the green was the first section we did, and then the yellow, and then the purple, and then the brown, and then the blue, and then the labs that we did, and then there's some demos, and then covered by our heads here are the wonderful things over there. So we're just going to take this section by section, and I think I'm going to highlight kind of the important things to take away.
Excellent.
Okay. And so then we're going to talk a little bit about the, this is actually a copy of the benchmark. Don't try to pause the video.
You're asking that?
Yeah.
No, I'm kidding.
JK. Yeah. And so, but I'll show you the blank side and not the question side, so you can't pause the video and enlarge it.
What's your social security number?
Yeah, well, you know. Okay, so let's go through this guy. Let's present this thing and do this up here. I'm going to move this. Whoop. And now, boom. Boom. Right.
Okay.
And so I think the important thing to do, this was really after years of teaching that I realized that everything that was in Unit 1 had to do with making observations.
Yeah, for sure.
Yeah, like numbers and metric system stuff. And so it's really focused. The benchmark is really focused on those observations. Yeah, so anyways, so that's what it's all about. Okay, so the first thing is the tools of making quantitative observations, which is that green section that was, well, let me...
Green's my favorite number.
Yeah,
Color.
Yeah, that's my favorite letter, too.
I was thinking quantitative number. I love green, so I said green's my favorite number, but I meant color, but it's
yeah, whatever. Okay, so
can you edit that stuff?
I don't know. No, I'm not going to, because it's more funner if I don't. Yeah.
I see what you did there. Oh, Ralphie. Okay.
I think for the metric system, when I'm assessing them, I think I'm going to have not a lot of metric conversions, because because you can get Google to do all those things. But I think I'm going to spend a lot of time talking about how you make observations using the metric system, or
excellent.
interpreting observations using the metric
system. Is that
system.
like if you want to find the length of something, you would use metric stick, or like, is it like, what you talking about here? Yeah,
that's a good question. I think what I'm going to have is like a bunch of data, but it's given in like metric units, and maybe like, hey, here's a whole bunch of data that maybe like something in kilometers and something in centimeters and something, and like, hey, which one's is this accurate or precise, or because
okay.
That, like application, So yeah, they have to convert, but it's more like, hey, here's some stuff. So yeah, I think that's what I mean by observing, and I think it's also important that the writing assignment that I gave my kids is all about like, hey, should the world adopt a uniform system of measure? And I think whether they said yes or no, I think that the take-home point is that the metric system should be easier to use, and I think that there may be some things that refer back to that, like, hey, yeah, the metric system is probably easier to use, whether we should all be using the metric system or not. So that's kind of what we're going to talk about in the metric system, but I would say that the metric system as a standalone question is probably not as important. There's not going to be like a list of conversions and do these conversions. Yeah.
There probably will be on mine.
Yeah. Well,
Sorry, academic kids.
yeah. The next thing is using significant figures, and we all know
Siggy Figgies!
She's so much funner than I am. More funner.
I'm so much funner.
Yeah, more.
All the funs.
Yeah, all the funs are happening there.
It's just because of Ralphie.
Ralphie.
He's so cute.
And
kids get nervous about sig figs, so here's the cuteness.
Right.
Yeah.
Sig figs. Blah. I think that when we're talking about sig figs, we're going to apply it to data as a like. Are these sig figs correct, or what does it mean to have a significant figure? You know, as opposed to how many sig figs are in these numbers? You know, not a list of things, but just like, hey, right? Does that make sense?
So more like, here's a graduated cylinder. What's the measurement? Is it 32 milliliters or is it 32.0 milliliters?
Oh, probably even deeper than that.
Oh, tell me more.
Yeah. So again, list of data.
Right. Okay.
And so
I'm visualizing.
Yeah. Here, I can even have you visualize even more. Yeah. So a list of data. Or maybe even another list of data.
Right.
And I could say, discuss the significant figures. Okay.
Thanks, Ralph. Okay.
Yeah. Or what does it mean about the significant figures in this set of data? Like, you know, like, so what's going on in the lab?
Who used the most precise instrument, sort of thing?
Yeah.
Okay.
Right. Yeah. So like, and so it's about knowing what a significant figure is and how they're figured out, and then applying it to a set of data. Again, all of these under the context of you want your observations to be as good as possible, right? And significant figures help us to do that, right? Is that what you mean?
That's a nice question here. I like how you set that up.
Yeah, I kind of like it. And there's like two different types of things there, so I think everybody likes it.
Oh, I bet they love it. Yeah. Okay.
Oh, I was like, wait, that's the same thing. Okay, so the purple section, which was down at the bottom of the thing, had to do with accuracy and precision. And so this is kind of a secondary question, but I think is kind of the crux of kind of the labs that we've done.
Okay.
Is your data accurate?
Right.
Is it precise? How do you apply that to the data, and then can you make statements based on that? So you have to know the definition, but you have to explain, but then you have to use the observations and the data to explain why you know that or how you know that, right? Which is kind of what we do in the lab all the time anyways. That's what scientists do. They make observations and they say, are we right? Are we not right? Yeah, does that make
Ralph
sense?
agrees.
Ralph? Yes. Okay, great. Did I just become that guy? Like that dog guy? Okay, that was weird.
He's so cute.
Okay.
Oh my god.
So notice that... let him run around.
Running.
Notice that the whole thing has to do with incorporating observations somehow. Like that's just what's going on.
Unit 1.
Unit
1 strikes again.
Oh, physical and chemical changes. Did I go? Yeah. See, woo. Okay, back, forth. Okay, this is the brown section.
So I love that you put physical and then chemical changes brown, because whenever I think about chemical changes, I think about burning stuff.
Burning stuff?
Well, because you know, you're not, if it turned brown.
Yeah.
So
burning is chemical change, right?
Well, yeah, right, and then you have it right after that.
There's like a whole bunch of keywords that imply chemical change. Like
fact.
Burning, rusting, exploding, blowing up. Combusting. Yeah, that's a way technical one, though.
That's exciting. Oxidizing.
Yo, what does that even mean?
You'll find out.
And so I think it's important, again, to identify what the differences are.
Breaking down would also be, I was thinking about something else.
Those are all, that's chemical changes, right?
Chemical change, sorry. I was still thinking about that.
Yeah, chemical changes thing.
Okay, now I'm with you.
You're with me?
Yep.
Yeah, so it's all about using, again, chemical, physical changes as evidence. Right, observation. Can you identify what a chemical and physical change is? Do you have observations that back that up? Isn't there a song back that up? No, I don't know.
Yeah.
Something like that?
I don't know it. I'm not cool.
Yeah. Neither am I. That's why I don't know.
No.
Okay,
cool.
So I think we have to know the difference, too. So what are some keywords? Physical change? Oh, the one that students always want to get wrong. Physical change or physical properties. Like boiling, state changes, right? Like if you boil water or iron or anything.
Yeah.
Right, that's just a physical change because you still have the iron. It's just
So you're saying kids confuse what a property is versus a change. Is that what you're talking about? So like the boiling point is the property, but the actual act of boiling is the change? Is that what you're...
Well, that's part of it.
Okay.
But it's more like, hey, boiling, people will say that it's a chemical change.
Oh, no. No.
Yeah. So yeah, I think it's good to kind of clarify the difference between physical, meaning, hey, the things don't change. The particles aren't changing around.
Yes.
Just moving and stuff. Which goes back to the particulate theory of matter. Whoa, particles splitting up or just moving further apart.
Oh, okay. Yeah, I knew that theory.
Ralphie did.
Ralph knew.
Yeah.
So I always go back to water for that, though. Like, you know,
Water?
when you boil water, it's water vapor. It's still water.
It is still water.
And we're so used to water, it's so easy to think about. You know, like, if I freeze water, it's still ice, which is still water.
Right.
H2O. What up? Like, you know, if it's still H2O.
Right. Yeah.
Still
I think
H2O.
that's exactly...
Okay. Not to be confused with absolute zero.
Okay.
0 Kelvin.
Oh, chemistry jokes.
My bad,
Mrs.
guys.
Dominiak, in the WSQ, you're going to have to identify whether you want Mrs. Dominiak back or not. For her, no matter what, she's going to know
Poor
that you say
Ralphie.
yes. She's going to know you say yes. No, but so the states of matter, when we're dealing with that blue section, that's when you have to know the particulate theory. Like, hey, because what's the difference between a solid and a liquid and a gas and their movement? And we even did a demo in class where we like took the particles. We did it on the smartboard.
Okay, tell me
It was
more.
it was a FET. Do you know FET?
I don't know if that. Was that
power?
PHE?
Yeah.
Oh,
Yeah.
I've called it. I don't know what I've called it.
I don't even know if I'm. Yeah.
In my head, there was some
Colorado.edu, whatever.
Yeah.
Yeah, and so you can take the particles and push them together, and you can
Stop
say,
it right now! I didn't know that.
Yeah, shut the front door.
I just make my kids dance really awkwardly in class.
Yeah, it's kind of cool. Yeah, so
different music, you know.
Jake and I, Mr. Weingrad and I, danced really awkwardly in class.
Nice.
That's what we did. We held hands and maneuvered around, and we were talking about the intermolecular forces holding ourselves together versus the bonds that are in our body that aren't going to change.
Absolutely.
Yeah, and so it's all about like physical, you know, you can increase the temperature and, you know, all that particulate theory stuff is what changes.
Love it.
Yeah, it's good stuff.
Love it. I'm going to check out that FET.
Yeah, it's pretty cool. I'll show it to you. Yeah. It's cool. I think that's actually one of the demos that I didn't list when I was talking about all the demos and how they apply to making observations, but whatever. Okay. Yeah. Let's see.
What do you mean describing different types of matter? Is that the solid, liquid, and gas, by the way?
Oh, yeah. So that's
excellent,
using the particulate theory of matter to describe, you know, solid having the particles very close, liquid where they're able to, yeah, right.
I think that registered really well, by the way, that movement.
Yeah. Well, the fact that we both did it without rehearsing this probably indicates that it's something to know and that something we've both been taught in our careers here.
Yeah.
Also, I guess you could apply that to, you know, substances and mixtures because we did the separation lab.
Right. Okay.
You know, and so like, hey, are the particles easily separated? Is it heterogeneous? Is it homogeneous where you have to do something a little more difficult?
So you say homogeneous, I say homogeneous.
Yeah, it's, you know, tomato.
I'm wondering if that's like up here. Ever since I moved up here, everyone says homogeneous.
I don't know.
I've always heard homogeneous.
You know what it's not?
It's not.
In biology, people learn about homozygous.
Right.
And I get that all the time on a test. They'll be like, it's a homozygous mixture.
Yeah.
And I'm like, no.
It's not two same alleles.
Don't be that person. Don't be that person that puts it's homozygous.
Same prefix.
Same prefix.
So at least
homozygous? No, it doesn't work that way. No. But it's homogeneous.
Come on.
I say homogeneous. You could say homogeneous.
I just
Because it kind of rhymes with heterogeneous that way.
it's just,
Yeah. Substances.
I don't know if anyone actually said it to me though. If I just do that in my head, Ralph, what are you doing?
He's getting into things.
Oh, I just wanted to climb up, guys. That's Ralph's voice.
Yeah.
Okay.
I just wanted to climb up on something.
Yeah.
Okay, and so we did some lab.
Yeah.
I think we did the same labs, actually. Like the rotten egg lab. And
I haven't done that yet.
Oh, smelly.
I know. I'm
Right,
excited.
you're going to do it, though,
I'm
right?
doing it at the end of this cycle.
Yeah, and the separation of a mixture.
Did it today.
Yeah, good stuff,
so
right?
Exciting.
Yeah.
I was so excited when they all separated well.
Yeah.
You told me it would work.
Yeah. You didn't believe me.
I mostly believed you.
Yeah.
And then it was amazing.
It was amazing.
It's amazing.
But I think regardless of the lab, what I'm really trying to hammer home with my students is that you have to use the observations and the data, which are still just observations, quantitative versus qualitative observations, right? But you have to use that data to support your conclusion. No, that's okay. Yeah. I like Ralphie.
Well, Ralph is really
excited.
He's got glitter
on his nose. He's all dressed up for the
He has glitter
lab.
on his nose?
Yeah. Now it's on my hand. Maybe it was just boogers. I don't know. But whatever. But the point is that...
What kind of observations could you make about that?
Right, it was shiny. And
Which is qualitative.
Right, qualitative. It was about 2 millimeters long.
Oh, quantitative.
Right. But you have to use those observations to support whatever conclusion you're coming up with, right? Like, that's the whole point of the lab.
Exactly, yeah.
Right. Yeah, observations. Yeah, I don't know. Okay, and so we did a whole bunch of demos.
Gorilla?
Yeah.
What?
So we did...
Do you do any gorilla impersonations during this? Excellent.
That's more of a monkey than a gorilla, but whatever.
Okay, fair enough.
Hey, look, Ralphie's doing stuff here. But no, so the whole point is that observations... There were people bouncing a basketball, and a gorilla walked through the middle of them bouncing basketballs. The question was posed before the videos, how many times does the team in white bounce the basketball? And so everybody's so focused on the basketball bouncing that they miss the gorilla walking through.
Really?
Yeah. It's called selective observation or selective attention.
Okay.
And so the point is that you're paying attention to something because you want it to happen, as opposed to what's actually going on, and you have to make sure when you're doing observations, you have to make sure that you don't miss the gorilla.
Oh.
Right.
Okay.
So scientists go in without a preconceived notion, or try to, like nobody's perfect, so you just, you do the best you can, right?
Great.
And then there's the crime scene where they have to look at a picture and, again, make observations, and then they answer questions, and then you say, well, what's preventing you from making all these observations? Time, you forgot to write it down, I don't know, like, there's people that know the right answer, but because we did it as a class, people were talking other people out of the right answer, so it's hard sometimes to do it as a group.
Right.
So observations need to be immediate. They need to be right. You don't want to miss the gorilla. That sort of stuff. Let's see, what else?
I worked on crime scene apps for the military when I was doing DoD. TSE, Tactical Site Exploitation. You have to go into a...
She works for the military, folks.
I did. But yeah, they have to
She can't tell you that she still does. Go ahead.
Okay, so they go into like a crime scene, like after a raid or something, and then they have to like quickly say, this was here, this was here, this was here, and there's a time crunch, and you have to be able to say like what they found, because they're bagging everything into evidence, and when they get back to base, they have to say, oh, this was all here, and we made it for the smartphone for the Army.
Yeah, that's cool.
So,
hey.
Future.
Right.
If anyone joins the Army.
Let's see. So again, all those demos that we did.
What was the steel wool? Is that the
that was
temperature change?
No, that was
okay.
That was we burnt steel wool.
Stop it!
Yeah,
what?
and we found the mass of it before we burnt it and the mass after we burnt it.
Okay,
and so we decided whether we were doing chemistry, and we were using that was our first like exposure to quantitative observations.
Okay.
Yeah. So and then we used those quantitative observations to decide if we did chemistry. Yeah, we did chemistry because there was a chemical change because the mass changed the steel wool.
Where'd the mass go?
Yeah, smoke and fire and stuff. So it was pretty cool.
Exciting.
So that was like the first time we used numbers to do it. The first time we used qualitative. Now we're using quantitative. And then the density, you did the soda.
soda.
Yeah,
love that one.
Yeah, it's pretty cool.
Yeah.
Again, probably a pretty standard demo for most people. Right.
It was not standard until I came here. My other schools, I've never heard of that. It was amazing.
Oh,
it was so exciting.
Yeah. And
yeah,
I think
some of my regular sodas, though, did float.
Yeah. It's pretty crazy, huh?
Why?
Density.
It didn't help me at all.
Right. It's because those are less dense than water.
They were the same as the other regular Cokes.
So the
So I'm gonna
goal...
throw those ones away.
Right. Well, we don't have to tell the students that sometimes things get a little wonky.
No, you should tell us that sometimes things don't work out in life, and it's okay. Life lesson.
Right.
The more you know.
G.I. Jane over here.
Yeah. All right, Oobleck.
Oobleck. Again, that was more qualitative observation.
Right.
Talking about states of matter. Right.
Non-Newtonian fluids, as
That's
my
right.
husband likes to say when I do this lab.
Oh.
He'll even you're doing that non-Newtonian
Newtonian
fluid
fluids.
lab. I'm like, I am.
You're big timing him.
Yeah.
No, he's trying to big time you, and you're like, I know more chemistry.
Well, he's a
So
chemical
stop.
engineer. It's okay.
He's
He's a smarty.
right.
Not as smart as Ralphie.
So I'm going to give you an opportunity. Again, Mrs. Dominiak has not seen the test except for what's in front of her now. Okay, so I'll give you an opportunity to look over the test. Yeah, right. Oh my gosh, that one obscure fact from one of the videos that you said. No.
What color dress was she wearing?
Yeah, funny because she's not wearing a dress right now. I don't think you're wearing a shirt.
Oh, I thought you meant from a video. I'm so confused.
Yeah, but you weren't in any of my videos. This is the only video you were in.
Oh, I
of
thought
mine.
I was thinking YouTube.
Unless
I don't
Jake
know.
was wearing a dress. I don't know. He I don't know. Whatever. So I was just gonna say, as I'm blabbering on for a little bit, just to close this video out. Is there anything that you want? Do you want to look over the exam and?
Yeah, can we freeze it?
Yeah, we can pause. We can do all sorts of stuff. Here, we'll be back quicker for you guys than for us. Oh. So what did you think, Mrs. Dominiak?
Oh my God, study. Study everything. Study changes, like physical, chemical. Know the difference. Know the difference. The particulate, describe it, just like a solid liquid gas. You know what it is. Precision, accuracy. Everything we talked about.
Ah. Is there anything in particular that you wanted to point out to my students?
All the things.
All the things?
All the things.
Okay. Well, there you have it.
Dominiak out.
Dominiak out! Okay. Have a great day, everybody.